Next, let's look at the two approaches to deal with categorical data. Ordinal encoding converts categorical data into integer codes ranging from 0 to the number of categories minus 1. For example, let's look at how to encode maker. The approach we will take is that each unique maker category is assigned an integer code ranging from 0 to 2. Similarly, we can encode the color category, as you can see in the slide. Now, let's look at the transformed data set using these two encodings. You can observe, for example, the maker for the first row is guess and the color is blue. The transform table now only has numeric values. Unfortunately, this simple approach has also some drawbacks. Because we assigned a range of integers to the categories, we have implicitly assumed there is an order between categories. For example, we are implicitly assuming that red is less or more important than green, which in turn is less or more important than blue. Let's explore another approach that aims to eliminate the particular problem. One-hot encoding is often the recommended approach. How does one-hot encoding work? For each categorical column, a number of n new columns are added to the dataset, where n is the cardinality, the number of distinct values of the column. Each column corresponds to one of the categories, and we will have a value of 0 if the row has that category, or 1 if it hasn't. For example, our original dataset is transformed using one-hot encoding as follows. Each category value now has its own column, and for each input row for a given category, for example maker, we'll only have one of the maker values as 1 and all others as 0. For example, in the first row, guess has a value 1, and in the second row, Tilly's has a value 1 for the make category. As you can see that the first row represents maker as guess and color as blue, because both guess and blue have the value 1 in their respective categories. This approach eliminates the problems generated by ordinal encoding. Unfortunately, it has some problems on its own, the most important one being the potentially large numbers of columns that get generated.